Okay, so we were working with some of the properties of exponents when they were dividing, and we said we had to subtract the exponents. Okay, so if we have something like this, this is so much better. All right, so in a case like this, you're going to take this apart. We're going to take the 3 and the 6. We'll reduce that like it was an ordinary fraction. I'm just going to put a 1 there for the heck of it. I have an x to the second and an x on the 1 on the bottom. So it's like I have 2 x's on the top and 1 on the bottom. The 1 on the bottom is going to cancel. It's going to give us 1 on the top. Then I have y to the 5th and y to the 7th. So I have 5 y's on the top and 7 y's on the bottom. So 5 are going to cancel. Gives me 2 on the bottom. Okay? So that's what that would look like. So basically, and we're using the properties of exponents where we're subtracting, okay? But you can think of it as also as like kind of a cancel thing. All right. I did everything to the 0 power. Then there's some like this, where they put a variable on the top and something else on the bottom, and they have it on the outside. All that means is that you're just going to have this twice, because it's squared. So that's going to be y squared over 16, not y to the 12th, y squared. Okay? So that property just basically, you're going to take that square to both of those things on both of these terms. So if we have one like this, 2x to the 3rd over y to the 2nd, and we're taking that to the 4th power. Okay? So then we're going to take each one of these to the 4th power. So that'd be 2 to the 4th, x to the 12th, because we're going to multiply, and y to the 8th. And then we should always figure out the numbers. So whenever you have that situation, you just always want to figure that out. So 2 to the 4th, you can use your calculator on that. Depending on what kind of calculator you have, usually it's like there's an XY key or the shift key that looks like this. Okay? To the 4th equals 16. All right, you might have this kind of a key there. It looks like an upside down V. That was bad. I'm having fun tonight. Okay. I'm just looking at some of the different ones we have here that you're going to have. Okay, so again, like this one, reduce the numbers first. That's going to be -2, and then power on the x. So we have 12 up top, 8 on the bottom. So that's going to leave us with how many? 4. Where at, top or bottom? Top, yep. Okay, good. That's how that works. Okay. So that's pretty much everything from 5.5 except ones like this, and they're not a whole lot different. Come on. goodness. I'm just going to go to a whiteboard pretty soon. There we go. So when we have a situation like this where we're actually going to divide, and that's what this is. That's what they're going to ask you to do, is divide. Then we want to take this and divide it into each and every one. Okay? It looks kind of messy, but that's what you're going to do. We're going to divide into each and every one of these. Okay? So 6x cubed divided by 2x. Here, let me break it up so you can see it better. Okay, so now we're just going to divide this. So that's going to give me a 3x squared. Going to divide this, so it's going to give me a 2x, again, because these x's are canceling out, and it's going to give me a 4 there. All right. So that they just called, you're just dividing there. All right. It says divide the polynomial by the monomial. That's what it says, but you're just dividing. Okay, same thing here, so we're just going to divide, divide, and divide. You got to make sure you do all three of them. Okay, so we have y to the sixth and a y to the second. We're going to divide those. That's going to give us y to the fourth, y to the fifth, y to the second. We're going to divide those. It's going to give us y to the third, y to the fourth, y to the second. We're just going to divide those or cancel. And that's what that looks like. Okay. But it has to go into all three of them. All right. So if you get something, I don't think you will, but if you ever do, where you have 4x to the third plus 8x to the second minus 12, all right, and you divide that by, we'll put an x there, a 3, all right. 3 doesn't go into 4, doesn't go into 8, it does go into 12, but we can't really divide this because it has to go into each and every one of those terms. Okay? So we really cannot divide that. It has to go into all three terms.
It would just 2 on the bottom side, it would just be 2x, 3, 4x, 2, 6x.
So Ryan, you're saying what if we just had a 2 down here? Yeah, then you can divide it because 2 goes into each and every one of these, right? Okay. So 2 goes into, it leaves us with what on the top here? What are we going to get? 2x3 plus 4x squared minus 6x, right? Yeah. That one's okay because it goes in all three of them, but 3 won't. And they'll probably toss an x down here on the bottom when they do yours. Okay. Good questions, and you'll get a chance to practice some of those. So, shortly. All right, last section. Okay, 5.6. So let's take a look at that. So in this section, they're going to talk about the last little property of exponents. and that's negative exponents. All right, so if we have, say, an x to the negative 4, all right, what does that exactly mean? Well, if we play around with some numbers, okay, so for example, if we try, let me go back to the calculator, let me try 2 to the negative 1, start simple, and push that little x, y, 1 negative. That's not what it should do. 2 to the negative, nope, doesn't like that. 2 to the 1 negative equals 0.5. So if we have 2 to the negative 1, that's going to be a half. All right? If I go 2 to the negative 2, I get 0.25. So 2 to the negative 2 equals 1/4. All right? And we'll start to see a pattern. Two to the 3 negative equals 0.125, which is 1/8. All right? Does anybody see what's going on with the negative exponent? What's changing? Huh? It's division. Okay? So when we see a negative exponent, it changes from a regular whole number to what kind of a number here? A what? A fraction. Changes to a fraction. Okay? And that's exactly what's happening. So we're getting some division and we're getting some fractions. Okay? So this would be 1/2 to the first. This one would be 1/2 to the second. This one would be 1/2 to the third. Okay, so the negative exponent is forcing the 2 to become a fraction. So in our properties of exponents, we say if we have an a to a negative n, then that's going to be 1/a to the n. So it flips it. All right? So if you have a negative exponent, it's going to flip it. That's what's happening. So if we have an x to the negative 5, that's going to be 1/x to the 5. Bless you. So we don't get the negative, just moves this down here. Nothing here becomes negative. And once you move it, the exponent goes to positive. Okay, so it's not changing. All right. So a lot of people kind of get confused. They think either the term itself becomes negative, or they forget that once they move it to the bottom, it changes to a positive. If the negative is on the bottom, then it moves to the top and becomes positive. So if the negative is down here, then it moves to the top and becomes positive. So it's flipping from the bottom to the top. That's what happens with negative exponents. So they're going to ask you to do some simplifying, first of all with some numbers. It's basically a simplify. And you never want to write things with negative exponents. So you'll see that in the directions, no negative exponents. Okay? So it's like some mathematical taboo. You never want to write a negative exponent. Okay? Except in scientific notation, which is kind of odd, but that's... So if we have 2 to the negative 5, then that's going to be the same as 1/2 to the 5. Okay, so they're going to, that's all you have to do. And then they might ask you to do, and figure out what that is. Okay? Since it's a number, it's easy to do. Okay, 1 over 4 to the negative 4 is going to flip to the top. Become 4 to the 4th. I'll use my calculator. 4 to the 4th. 256. Negative exponents, bottom to the top. Top to the bottom. If we have something like this, okay, and this one confuses people too. So what happens here is only this one is negative. All right? So then that x to the 4th moves to the top. But there's already 2 there, so it combines with it and becomes x to the 6th. Okay, so if you got 4 that are negative, it's going to bump up to the top, combine with the 2 that are already there, and give you x to the 6th. All right, the 2 is not negative, only the 4 is on the bottom. So the bottom moves to the top, but the top doesn't move, it stays. Same thing on this one, okay? The 3 is negative, but it's only there to throw you off. It has to be the exponent that makes things move. So this negative 8a comes up here to the top, combines with it, 8 to the 12th. All right? So you kind of have to be careful with negative exponents. Then they're going to have some that look like this. 4x to the negative 3rd over 6x to the negative 5. Okay? So, first we're going to reduce 4 into 6. There's a couple ways to do this. This negative got to go to the top. This negative's got to go to the bottom. So they're going to switch. This one's going to go to the top. This one's going to go to the bottom. Now I have 5 on the top, 3 on the bottom, so that's going to reduce down to 2. So it would look like that. Okay, that's one way of doing it. The other way, you're still going to reduce that fraction. Is to use your properties of exponents that says when you divide, what do you do with those exponents? What are we going to do with the exponents if we divide them? Remember? Subtract. So if we take negative 3 and subtract a negative 5, it becomes a plus. So there we go. So you can do it that way. So it really doesn't matter which way you do it. Again, you got to find the way you understand it, all right, and make that work for you. Okay. Negative exponents are pretty tricky, actually. I'm just doing some things here that I see that they're going to have you do. Okay, so let's try one like this. Okay, so I got a negative exponent on the outside. That means I got to bring that inside to each one of my exponents here. So I'm going to get 3 to the negative 2nd, x to the negative 4th. And I'm multiplying because I'm raising this to a power, y to the 6th. So I just took this -2, multiplied it to each of the exponents as I'm raising it to a power. That's what my properties of exponents say. I'm going to work on that first. It's a negative exponent. It's going to flip to the bottom. Negative exponent is going to flip to the bottom. Positive exponent is going to stay to the top. And it's got multi-colors going here. Y to the 6th stays to the top. 3 to the 2nd is 9. X to the 4th stays x to the 4th. Okay? That's pretty much the best way to doing those ones. Okay? Let's try another tricky one.
Real quick.
Sure.
Why is there a 1 on the top?
That came from the 3. I just put that because the 3 to the -2nd, so it's going to move the 3 to the bottom. And so it's kind of like it becomes 1/3. You really don't need that 1 there. I just put it there just kind of so you see what the number went to the bottom. Okay. Okay, something like this. Okay, they're getting pretty complicated. This is about as complicated as they get. So my choices are, I can work with what's inside the parentheses first, or I can move that 2 inside. So you have 2 options here. Both of them are right. So let's go this way, and I'm just going to work inside first. Okay, so I'm even going to ignore that. So I have a 3 on the top. I have an x to the 2nd and an x to the -4. What's going to happen to that x to the -4? Where's that going to go? I'm going to go to the top. How many do we already have on the top? 2, so that's going to give me x to the 6th. Good. -4 comes to the top. Gives me 6. Okay, now I'm going to do the same thing with a y to the -1. Okay? Y to the -1 is going to move to the bottom, but I already got 7 there, so I'm going to have y to what power would that be? 8. Okay, so I worked inside first. So I did what's inside the parentheses first, kind of like the order of operations. Now I'm just going to go ahead and raise everything to this power, to this power, to this power, to this power. So 3 to the 2nd, x to the 12th, I'm multiplying these powers, 4 to the 2nd, y to the 16th. And now I'm just going to go ahead and do the numbers, leave the exponents there alone. Okay? So that's one way of doing it. Working inside first. Another way, let's see, what was it? 3 x second y -1 over 4 x to -4 y to the 7th. Okay, to the 2nd. The other option would be to do the power first. So I'm going to do this first. 3 to the 2nd, x to the 4th, y to the -2nd, 4 to the 2nd, x to the -8, y to the 14th. Okay? So I do that first. Now I'm just going to simplify it, so I get a 9, I get a 16. I have x to the 4th here, but I have an x to the -8 here, So what's going to happen to the x to the negative 8s? Where are they going to go? Negative exponents are going to go where? To the top, right? So I already got 4. Now I have 8, so how many total will we have? 12, good. Here I have a y to the negative 2nd and a y to the 14th. It's a negative exponent, so it's got to go down to the bottom and give us that. Notice that that's the same answer as we have there, okay? So again, it kind of depends on which way you want to do it. All right, so you can either go ahead and do what's inside the work inside first, or you can do the power first. All right, it doesn't matter to me which way you do it. Again, I just want you to do the way you feel comfortable in doing it so that you get it right. Okay? There's no right or wrong there. It doesn't make any difference. Okay. Now we'll go to, let's do our last real complicated one here. I'm going to do one like this, where we have x to the 3rd and an x to the 2nd, and this is to the negative 4 power. Okay? So we kind of did one like this. So again, we can go like this here. Okay? Move this to each one. And then simplify it. So I got 12 here and 8 here, 2 to the negative 4 there. Things are going to go flipping all over the place. Where's that 2 to the negative 4th? Where's it going to go? To the bottom. Good. Okay. X to the negative 12th. Where's it going to go? But where's it going to go? Top or bottom? Bottom. Okay. X to the negative 8th, where's it going to go? To the top. All right, now you'd simplify that. Okay, so 2, I know that's 16, I already did one of those. X to the 8th, x to the 12th is going to give me x to what power, and where is it going to be? Bottom, and x is going to be to what power? 4, good. All right, good job. Okay.
Why does this 2 to the 16 lines out on the bottom?
2, because 2 to the negative 4th is on the top.
Oh.
So it's going to go on the bottom, right? So negative exponents are really kind of tricky. The best thing is just, it's going to flip. It's going to, if on top, it's going to go to the bottom. If it's on the bottom, it's going to go to the top. Okay? That's about all I can, that's the basic rule there. They have some stuff on scientific notation. And you did this, I think they do some in Math 60. Kind of think they do. I don't know how useful it is for you, although I had some nursing students who told me that they used it. So, okay. So in scientific notation, basically, here's how it works. It's just supposed to be a quicker or smaller way of writing very, very large numbers. All right. The rule is you only can have one number to the left of the decimal point. Okay? So this is basically the same as taking 8.3 times 10 to the 6, which is 6 zeros, okay? Which is basically 5 moves of my, or 6 moves of my decimal point. 1, 2, 3, 4, 5, 6. So it would be that number. All right? In the other sense, if we have 4, 5, 6, and a whole bunch of zeros, to write this in scientific notation, I can only have one number to the left, 4, 5, 6. So here's my decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. All right? Now, some calculators use, this is written as 4.56E, a capital E 11. All right? It kind of depends on what calculator you're using. If you're using your, let's see, I don't know what it is on mine, which is pretty close to your phone probably. I think I have a 10 to the x right there that I could use. I'm not sure what they do in decimals. I'm just not really sure. But some buttons have a capital EE on their calculator. If you see a EE, that's scientific notation. EXP is sometimes scientific notation. Kind of depends on what kind of calculator or device you're using. Okay? So if we take, one of the things they have you do is they have, say we have 2 times 10 to the 14th, and we're going to multiply that by 3.6 times 10 to the 15th, all right? Then really all I need to do is just multiply these two numbers and add my exponents, because this is, we're just using properties of exponents there. So I multiplied these two numbers to get to here, and then added these exponents. To get to that, okay? But your calculator will do it. So if I want to go 2 times, let's see what happens, 10 to the 14th. Let's see if it'll put that in there. No, it doesn't like it that way. Nope. I can do it that way. And then I would multiply that. I don't think this is going to multiply very well. No. I'm not exactly sure how it works on this guy. Let's see how it works on the decimal. So. Let's see, 2. You could probably go times 10 to the A to the B is the 2 to the key. 14 times 3.6 times 10 to this power 15, and 7.2, 10, 29. I don't think there's an EX. I'm looking to see if there is. No. So you just do it that way if you're going to do it in decimals. Okay? So if you have a question on your calculator, which way to do it, I can look at it and try to figure it out. Questions on the scientific notation? This is a very quiet group. Okay, so I'll give you some problems to work on. What I'm going to do while you're doing that is run off into the office and print off some test reviews for you, so you have those. And then get that for you. Let's see. Let's find some good problems for you to practice on. Let's see, we're doing 9 through 16. Let's do 11. Try those ones out. Remember, this assignment's not due till next Tuesday.